Okay, we're going to start at the top of page 375 where we left off yesterday. It isn't quite the second lecture, but we're today. So the top of page 375, the title to the example is this. It says, evaluating trig functions of quadrantal angles. And you're going, what in the world is quadrantal? Well, it's an angle that opens up right to an axis. So let me remind you, don't open up to an axis and what we do. For example, if I wanted to do one like to find all the 6 trig functions of 3 pi fourths, then what I would do to start with to figure out where I'm at so I can get proper signs and stuff on there, I would open this up from here to pi fourths, 2 pi fourths, 3 pi fourths. That would be in a second quadrant with a reference angle of 45 degrees. Or pi fourths. I probably ought to stick with the thing. This is the 3 pi fourths that we wish to find things for, but we use the reference angle in this triangle and proper signs on the legs, depending on whether we went right, left, up, or down, and always a 1 there. That way I can find all 6 trig functions now, right? Okay. So if they ask you to do the very same thing for pi halves, so the angle is pi halves, you say, okay, I'm going to open up an angle for pi halves. You open that from here up to here and stop. And try to draw your triangle. There's no triangle. Whenever you open an angle up to one of these 4 spots, or these 3 spots, this one, or this one, and that's the angle that you're talking about, which is perfectly reasonable, there's no triangle to draw. So now what do you do? Now you go back to the idea of this, and I'll draw it over here so that it's all together here. Remember I told you in a general way, especially if I stay in the first quadrant, if I open up an angle, any old angle right there, nothing special about it, that this right here is associated with the cosine of theta because it's adjacent over 1. And this was associated with the sine of theta. So that it's this point at the end of that terminal side, instead of calling that xy, we could call it cosine theta, sine theta, right? And if this was not 1, but r, just some radius that we opened out there, that this would be r cosine theta, and this would be r sine theta. Do you recall that? Okay, so that's true of any point on this unit circle. It's true of any point. So if what I do is, if I come out to here, right here, if I stick with the unit circle, a unit radius, then this point right here is 1, 0. This is the cosine of that angle, and the angle is 0. And this is the sine of that angle. Okay? One other thing I want to show you. I'm going to come back over here to this one. If this length right here, when this is 1, I'm going to go back to 1 for just a minute. When this is 1, if this length is the cosine and this length is the sine, then the tangent of that angle is sine over cosine. And that is what we call an identity. It's your first one. You're going to have about 28 of them. This is your first one. When it becomes important to keep track of these, I'll have you write that down. You may want to write that down right now, but it's always opposite, which is sine, over adjacent, which is cosine. And the really cool thing is even if this is an r, so that this is true up here, then the tangent of theta is r sine theta over r cosine theta, and it's still in the canceling sine over cosine. Okay, so with that in mind over here, then what we say here in this for this quadrantal angle, it means one on the axis that doesn't produce a triangle. We have to now go with the point which right here, and remember the first one's cosine, the second one is sine, and tangent would be this if we had to find tangent. It's all about that point right there. And so we say this, the sine of 0 degrees or 0 radians, either one, the sine of 0 is going to be 0 because that's sitting in the y position of that point on that quadrantal angle. The cosine of 0 is 1 because that's where it sits. The tangent is 0 over 1, which is 0. So sine and tangent are 0 at 0, but cosine is 1. It's weird. Here's a way you can think about it too, if you really want to draw a triangle. Just to give you an option for either understanding this or remembering it, or or drawing this for next time you need to have it. If you think of a little teeny tiny baby triangle here that is opened up to almost nothing, then your sine will be virtually 0 over 1, which is 0. Opposite over hypotenuse. You see it? Because the right angle is right there. Cosine would be 1 over 1, which is 1. See that? And tangent would be 0 over 1, which is 0. So if you want to draw a little tiny baby triangle, assuming that this is actually 0 and this side over here that's so short is actually 0, you can still use a triangle to get it, although that's a little contrived. Or you can go right directly to the point and remember that cosine comes first. I'm going to leave that on there. Okay, so if we open up the angle to here, so that the angle is now pi halves, which is originally what I wanted to do, then you got to think about where the point is on this one. This point right here is the point 0, 1. And remember, that's cosine, sine. And so at pi halves, what do we want to do? I'm going to put this down here so it's on the unit circle that I'm doing. Pi halves. Then I can go over here. Probably should have put that in red. The sine of pi halves is the second one, which is 1. And the cosine of that angle, the quadrantal angle, is 0. And the tangent is undefined. Because you can't put 1 over 0 and get anything meaningful. Tangent is undefined at that point. Tangent is also undefined at this one, and 0 at that one. So without drawing all this stuff out, can you tell me what you believe the sine of pi is? Just so you know, that's this one. What's the sine of pi?
-0.
Negative 0. No, just 0. What's the cosine of pi?
-1.
That is negative 1. And what is the tangent of pi?
0. Undefined. No, it's 0. It's 0.
It's sine over cosine, and 0 over negative 1 is reasonable. It's 0. You okay with that? I do have a blue one, but I don't know if it's going to work. So if we go all the way around, and the angle now is 3 pi halves, that's the last quadrantal one, because 0 and 2 pi are the same. So we've already done the 0. Okay, so with that angle, 2 pi third or 3 pi halves, that would be the sine of that angle, which is 3 pi halves or 270 degrees. What would that be? Good, negative 1. Cosine?
0.
Okay. And tangent? Okay. So those are the deals for the quadrantals, and they're ones where you can't actually open up a triangle. If you really want to, you can make a really, really tiny triangle. When I do it, if I were going to make a tiny triangle right here, you'd have to draw it so that it was almost closed up at pi halves. It would be like this. And the right angle would be here, and this would be your 0. So that the tangent of that, the sine of that angle would be 1 over 1. And the cosine would be 0 over 1, the hypotenuse. And the tangent would be 1 over 0, which is undefined. So you can draw the little baby triangles if you want. So you have a triangle at every place, but it takes a little longer. You go straight with the point. And by the way, if this was not 1, but 5, then the cosine would be 5 and the sine would be 0. The tangent would still be 0. You understand? It has to do with the point that goes out. So if your r is 5, then this is the point 50, and the cosine value is, that's not right. The cosine value is still 1. Always go with the quadrantal 1, 0, or 0, 1, or, yeah, those things. I got to think about that one. It can't be 5. It's not 5. It's 1. Cosine can never be more than 1. Neither can sine. Okay? Yeah, I'm talking to you because you asked me about the one that I said I'll be explaining here in a minute. Let's go back to that one, the one you were struggling with. Number 9. Number 9, that's 0, which means you haven't got anywhere on the x, but you got up 5. The sine there will be 1. And the cosine ended, well, the cosine will be 0, and the tangent will be undefined.
Why is the sine 1 if it's going up? Maybe that's a
I know why. It's because it's r sine theta. If it's 5, it'll be 5 sine theta there, and 5 cosine theta, and 5 tangent theta. The sine of the theta part is still just 1, okay? Okay, y'all right? On that part? So take a look at page 375. They've got three things there. This takes it just a little bit farther than I had, so let's try and do these. Example 6. Says find the following if it exists. If the value is undefined, write undefined. So we want to find the sine of negative 270. So it's not, these aren't just right straight up. You got to do a negative 270, which lands you here, where the sine is 1. Negative 270 actually lands you at positive pi halves, which is where the sine is 1. Follow that? Jen?
Yeah.
You sure? You just saying that?
No, yeah, I'm just, yeah.
Okay, all right. I just was looking for some sort of.
Yeah, no, I'm just thinking about the one from the lesson. Is
Were
that how you?
Were you really?
Yes, is that how you do 37 through 42?
Oh,
Because those are the ones, and I was like, you just do a little baby triangle, and I was like,
Yeah, you're right. Every one of those is a quadrantal. Yep.
Yeah.
Want to take the test?
you like it after school to take it?
No, you can't. Not today. Not Friday.
Okay.
Sorry, I've got an appointment right as my prep hour starts, and I'm not coming back.
Okay. So I'll come in a second. All right.
Okay, that's fine.
Right. Good luck, Sam. Thanks.
Once you do these on 2 separate papers, I want to copy it. It doesn't have a ghost at the end, so that I can send one or both in for you. So do a good job. Make me a nice picture. Go get them.
Do you have a straight edge?
Yeah, right up there. Cup. Okay, so let's go back to example 6. That'll explain how it's going on. It says to find the tangent of 3 pi. So you got to wind around until you've gone by 3 pi. Now this is how you do it. Start here and you go, there's 1 pi, 2 pi, 3 pi. So we are sticking out here. What's the tangent of that?
Undefined.
No.
No, that's 0.
0. Because you're right. No, because you're right here. So I don't know if you start to commit some of these things to memory. Tangent is 0 if you're sticking out, if you're going right or left. When it's standing up, because it's vertical and vertical lines have undefined slopes, right? Isn't slope rise over run? Rise over run, you run nothing. That's what tangent is. Rise over run, believe it or not. So tangent's undefined here, it's 0 here, just like slopes are for those two lines. Okay? All right, so then on the C part, the secant, we'll figure out what secant is in just a minute. As soon as we locate that angle, 11 pi halves. Wouldn't 12 pi halves be all the way around? 3 times or 4 times? 6 times? 11 pi halves then is a pi short of getting around there 6 times. So without going like this, it's going to land here because we're pi half short of getting around here to an even number of pi's. It's here. And the secant, what was the cosine? What's the cosine of pi, people? Look up here. Come on, don't look at who's coming in. What's the cosine of pi? -1. So what's the secant? Undefined. No, lie. Secant's -1. Reciprocal of -1 is -1. If I did the tangent of this, then it would be undefined, or the cotangent would be, because you got to flip it over. But the cosine was -1, so the secant is the reciprocal of that, which is still -1. Yeah.
Maybe the line facing down like this,
Oh, it
that
is.
it lands on
11 pi 12
11 pi halves because you go right.
was 11 pi, yeah, 11 pi half, right?
So instead of going like, you're just a pi half short instead of a full pi short. So will you be on the bottom one?
Maybe.
In the book, it has it pointing to the bottom.
Okay, yeah, you're right. You're right. I was counting pies because of the previous one, and I'm not taking this class for credit. It's my only excuse. Okay, so you're right. We need to count pi half. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're right. It is. So now that we're in the right place, because I'm ridiculous, the cosine there is 0, meaning the secant is undefined. So I was right to begin with, for completely, totally different, wrong reasons. But secant here is undefined because cosine is 0. Glad you guys are here, man. I really do. Oh. Okay, everybody okay? You may want to read that little blurb about why it says, why not use a calculator? We'll come back to it if we have time, but it is Friday and I got to move on.
12 pi over 2 would not be around 6 times.
What? 12? No,
Or would it be around 3 times?
yes, 3 times.
3 times.
Because 12 pi over 2 is 6 pi.
Okay.
And he's right, we were only a pi half short of that, which is only here, not there. Okay, example 7, finding cosine and tangent by using the given information to construct a reference triangle. We're looking for cosine and tangent on example 7. But we are given that the sine is 3/7 and the tangent is negative. That's how you interpret that, by the way, folks. Just so you understand what it means to be fluent in math, if you were like in kindergarten and just learning to read and decode and sound out words, you would sound out words very, very carefully, and you'd probably be very good at it. And then your teacher would say, now what did that say? You go, I don't know. And the reason why is because you were focused on decoding. If you are fluent in math, it means you can read the words so well that, and understand what they mean, that you don't actually have to sound them out. If you were still in the sound out stage, you would say, the sine of theta equals 3/7 and the tangent of theta is less than 0. This is what we're going to say. The sine is 3/7 and the tangent is negative. That's fluency. Where will the sine be positive and the tangent be negative? Which quadrant?
Oh, that'd be the second one.
The second quadrant, right? How do I know the sine's positive? Because 3/7 doesn't have a negative on it. That's how I know. So that's the first question you got to ask yourself is, where is sine positive and tangent negative? The answer is second quadrant. When you've decided that, then, because you have to find a correct quadrant, you can't get the right SIGNs on things. Sines. As in difference from sine. Sine different from sine. That's why I said SIGN, okay? All right? So you got to get the correct SIGNs on things. And so we have to figure out what quadrant it's in. That's why they gave you that little extra piece of information that tangent is negative. That puts you in the second quadrant. So when you get in the second quadrant, draw a triangle such that the sine is what it says it is, 3/7. So decide the quadrant. Draw an angle that, you should be reasonable. Sine's going to be opposite, and 3 is a little less than half of 7. So it's going to be a pretty lay down triangle here. This will be 3. This will be 7. And this will be
3 squared
Oh.
minus 7.
21 minus 9.
49 minus
Square root of 40.
better than that would be. Better even than that would be
2 root 10.
negative 2 root 10.
Yeah.
There's a lot of math there, trying to figure that one out. It was 49 minus 9, which is 40. So you knew that this side would be the square root of 40, but that simplifies to 2 root 10. Furthermore, it's negative because we're in the second quadrant. And this is theta, although we will use alpha with the correct signs on the legs to answer the questions about cosine and tangent. Now that we have everything worked out based on the information, what is the cosine of theta?
Negative 2 root 10 over 7.
Good. And what is the tangent of theta?
3 root of 10 over negative 20.
Negative 6 root 10 over 20. Oh, crap. That's negative 3 root 10 over 10. That's what it is. That's what you said. But you said 20, and we got them both mixed up, you and I. But what happened there was we took the tangent, which was 3 over 2 root 10, negative, rationalized the denominator. That gave us, oh, crap, you were right to begin with. Okay, negative 3 root 10, because it's a negative fraction, over 2 times 10 is 20. You were right. I was wrong. I've been wrong a lot today. Don't count on anything to be correct. Okay? But anyway, it's getting the triangle done, using Pythagoras to find it, putting the correct SIGNs on the legs, and then answering the questions they ask. You understand the whole process? Even though I don't know my arithmetic very well, I still know my trig, so I'm redeemed. What?
Never mind.
I think
You already
Sarah
have one for
was
you?
cheating.
You can't sit there. Sorry. No, you can't sit there. You can sit in the back of the room if you want, or you can take one of these desks here out in the hall, this front desk here, if you like. You can sit at my desk, but you cannot, oh, that's too close. No, you gotta go find another seat.
Yeah, why did
Oh, yeah, you need to find another seat. If you wanna take one out in the hall, I'm happy to get you an empty desk. You want to?
Take Liv's desk.
Can I just sit in Liv's desk?
Yes, you can sit in this desk, yeah.
think I won't.
And you can sit over here behind. You guys are experts at ignoring me by now, so I think you can stay in the room.
I think
and be
they're
okay.
cheating.
And if you need your book,
Two pieces of paper.
if you do, you may only see on page 612 in the next 3 pages. 4.
I forgot my book.
Oh, jeez.
I didn't bring my backpack
Dude,
to
here's
school,
your chocolate.
so.
Hold on there, Olivia. This recording is for you, but you know, all your band comrades are here taking it.
We're back.
612 is where it starts.
That's 6 and then
You got a book? Do you need a book?
I have one. I'll grab one.
All right. You have one, Mariah? Where's Mariah? You have one? A book? Keep your eyes on those pages only. Okay. All right, are we ready to move on here, Trig people? Okay, so the next one says secant is 3 and sine is positive. That's how you read it. What's associated with secant? Cosine. And is that cosine or is that association with cosine, is that positive?
Yeah.
Where are sine and cosine positive? First quadrant. It's the only place where they, well, yeah, it's the only place where both of them would be positive. So we've got a first quadrant angle to draw, and it says the secant is 3, which means the sine, cosine is 1/3, right? So if you want to draw this relatively to scale, you need to draw a hypotenuse that's 3 times long to the adjacent leg, so that the secant can be 3. Secant is 3, or is hypotenuse over adjacent. Do you see how I put those on there?
Yeah.
And so what is this?
Oh, it's-
Careful now, what is this? 2 root 2. Because 9 minus 1 is 8, and the square root of 8 is 2 root 2. Yeah? You'll follow it? And this is theta, and theta is the same as alpha this time, because we're in the first quadrant. That's great. So what is the what are we supposed to find? Yeah, cosine. What is the cosine of theta? We use that to get this thing on here. What's the cosine? What's the cosine?
Oh, wait.
1/3.
Ha ha, you made a mistake now. Okay, all right. Tangent of theta? 2 root 2. Yeah, that can be right. Yeah, tangent can be more than 1. Okay, and the last one says cotangent is undefined and secant of theta is negative. So they actually said the words out this time. They can give it to you in various forms. Cotangent is undefined and secant is negative. Okay, I have to tell you something here, and it is only good for trig. Do not carry this beyond anything else in mathematics. Only here. We will say, for the purposes of doing these kinds of problems, that the reciprocal of undefined is 0. That's not true in a lot of other mathematics, but in here it will serve us well. When they tell you that a particular function is undefined, then you take his reciprocal back and say to yourself, when is the tangent 0? See what I'm saying? And those things can only be 0 on quadrantal, so we got to figure out which quadrantal we're on. So it says the cotangent, or in other words, the tangent is 0. That's how you interpret that. The tangent is 0, and the cosine is negative, because if the secant is negative, so is the cosine. Where is the tangent 0? And the cosine negative? Is it? Cosine is undefined. No, cosine is -1 at either up or down. Where's it? Where's it negative? Which one? The down one at 3 pi halves. Right. I just wanted to. Brunson, I just wanted to make sure everybody else got it. Okay. So we're pointing down. That's where tangent is undefined, right? Wait, cotangent is undefined. Or tangent is 0. Tangent is undefined there. Secant is negative.
Let's look at this. So does it really
Cosine 0 there. You're right. Cosine 0 pointing down. Sine is -1. You suckered me again, man. She straightened me out. Cosine is -1 at pi. Tangent is 0 there. So the cotangent is undefined. Huh?
I still thought it was down for school. I was like, -1, 0.
Did I convince you? Shall I show you?
Okay, yeah.
Okay, all right. Take a look here. Take a look here. We're talking about tangent, because that's the reciprocal of cotangent. We're talking about the tangent is 0 and the cosine is negative. Tangent is 0 only here or here. And cosine is positive out here, it's positive 1. Here it's negative 1. So we must be at this angle. Does that make sense, everybody? Because this point right here is negative 1, 0, so this is the cosine. It's the only place that this is negative, and the tangent is also 0. So the cotangent will be undefined. That took me a while. That takes some reasoning there. So we're at a cotangent of angle, or cotangent, we are at a, what do they call it? What's that kind of an angle? What's this kind of an angle called?
Quadrantal.
Yeah, quadrantal. Okay, we're at a quadrantal angle of pi. Okay, so that's where we are, and we are to find the cosine and sine, or cosine and tangent of this. That's what we're doing with every one of these once we figure out where we are. What's the cosine of pi? Negative 1. What is the tangent of pi? 0. We already used that, okay? Okay. Notice that took a whole page. Yep. We're finally ready to give you this lecture for section 4.3. This was where I was supposed to land yesterday.
Wait, 4.3.
4.3b. Yeah. This won't take too long. Honest to goodness, this is a short little video. We should hope we make it.
Okay, we're ready.
We're not doing the wrapping function. I'm supposed to focus on the green box on the next page.
Circular functions or periodic functions? Neither. Let's just.
There's really only 2 things I want to show you. And that's the green box at the top of page 378. Are you looking at it? Green box, top of page 378. If you got your eyes on that, I won't need to put much of this on the board unless I really feel like I need to. Here's what it says. You guys look at the picture to the left of the box while I'm talking and reading. Look at the box, look at the picture. It says let t be any real number. T is that angle. And let p, which is xy, you see it up there, the cosine sine, I already talked to you about that, be a point corresponding to t when the number line is wrapped. No, I don't want to talk about that. I don't want to talk about wrapping. That's so confusing. Instead, notice from that angle right there, the angle on the picture that you're looking at, notice that the sine of t is y. Does that make any sense to you? It's talking about the point being xy as a point. The sine of t is y, the cosine of t is x, and the tangent of t is y over x, or in other words, sine over cosine. The reciprocals of all those are you just take those things and turn them over. If sine of t was y, then cosecant is 1 over y. What they're trying to get you to do here is to look further and harder and get more associated in your own mind that xy coordinates are associated with cosine and sine of the angle that turns that. You got to start linking those things together. XY points on that grid can now be written in terms of the angle that was flipped out to right at that point. In terms of the angle, cosine sine. And tangent is y over x, which is sine over cosine. It's also, that's a big deal here. Tangent of an angle is also the slope of the terminal side. The tangent of an angle is the slope of the terminal side. So, for example, the slope of this line right here is 2 root 2. Because it is rise, 2 root 2, run, 1. That is the slope. Okay? The slope of a terminal side of an angle, the slope of it, is the tangent of that angle.
Terminal side is a set of sheets.
No, terminal side is the one that stops after you open it. It's the one that's sitting up from the positive x-axis.
Oh, okay.
So the slope, when you open up an angle and you stop, of that terminal side is the tangent of the angle you open. Okay. Periodic functions. Do I have to tell you about this? Yeah, I won't tell you that. Last thing I want you to see is on page 380. There is a picture of all the important angles, the 45, the 45s, the 30s, the 60s, the 90s, the 180s, 270s, and 0. Those are all really important angles, and all versions of them in every quadrant are given to you on that unit circle, the 16-point unit circle. This is the one that Mr. Hill and the way he wants to teach things, thinks you should be able to have on a test.
Yeah.
You cannot, not in here. Get it straight in here. You gotta get it yourself in here. Really, all you need are the first quadrant angles. That's all you really need is to memorize those first quadrant things and then attach the appropriate sign to them as you go around the angle with reference angles the same size.
Oh, it's the same thing.
Yeah. Oh, with different signs on them. You only need to memorize the first quadrant things. And I don't even have any of those memorized. Honestly, truly, I do not. But what I visualize immediately in my mind is whether I have a lay down 30-60-90, a 45-45-90, or a stand up 30-60-90. And then immediately I've got things because I know where 1/2 belongs and where 3/2, where 3/2 belongs and where 2/2 belongs. I know where those belong on my visualized triangles. So you can do it that way, or you can actually memorize these. But really, first quadrant ones are the only ones you need to know, and then the all-student state calculus will serve you the rest of the way.
Well, if that's all I need to know, why can't we just have a paper?
Because you will look foolish when you take calculus and statistics if you don't know those. My objective is to keep you looking cool in your math classes, so stop it. You can't have one. Don't ask me again. Okay.
That'd be cool for rock stars.
Yeah. Well, take your rock star cannon, but don't take your paper.
Okay.
All right. So that's really all I wanted to show you. Actually, most everything that was necessary for the 4.3b was already given to you. It's just kind of reiterating. If you absolutely must go back to this for a few times while you're working through this assignment, go ahead. But after 4.3, you should not be using this circle. You should be figuring things out for yourself by either drawing triangles or visualizing them. Figure it out. Okay. That's it for that. Good luck with it. Bye.